The pace of digitalization is unprecedented, and it's completely transforming our world, harnessing new technologies across the landscape of industry to fundamentally change the way we live. The factory of the future will be created with intelligent connected machines that are both adaptable and extendable and can provide strategic operational insights to improve efficiency. It's all enabled by digital threads that turn silo data into connected disciplines and processes. These threads form the neural network of a digital twin, a virtual entity which mirrors the physical world, turning data into insight to continuously design, build, and optimize throughout the product and production lifecycle. This approach gives engineers new opportunities to create breakthrough innovation, leveraging virtual simulation and field intelligence to deliver customization and accelerate time to commission. Adaptable production lines reduce setups and cycle times, and a digital manufacturing process optimizes for quality and shop floor throughput. During and after field commissioning, the physical machine feeds data back to the digital twin, so teams can predict problems, proactively service machines, and improve the next generation of equipment. Siemens can help you achieve rapid digital transformation, powered by the world's most comprehensive digital twin. There's no need to dream about the future. It's already here.
Individualisierte Medikation.
Personalized medication means increasingly smaller production batches, and that means greater flexibility on the machine as necessary. This is precisely where we have to go with our system development. What drives us is enthusiasm for the things our customers are doing. They produce medicines that help patients, and this is what motivates us to supply our customers with better and better machines, so that our customers can even more effectively produce even better medicines. This drives us to continue to make improvements, which leads to innovations.
Bausch & Ströbel is a truly fascinating company because of the industry. Pharmaceuticals is a highly innovative field, one that is always coming up with new areas that present entirely new challenges to machine builders. This means that the chance to work with an enterprise like this is simply incredibly exciting for us. Why? Because this company understands digitalization.
Die klassische Automatisierung.
Classic automation was a sequential development. This means that the mechanical design came first, followed by the electrical concept, and then the PLC programming. You had to wait for these earlier developments to be completed before you could get started with automation. Today, development must be done mechatronically. This work, these three disciplines, have to take place at the same time. Only then can you be efficient.
Effizient zu sein.
Machine builders used to create a model at the drawing board. Then they'd build a wooden prototype from manufacturing and would show it to the customer. But when a fault occurred, when something didn't work out, they were right back where they started. But when someone goes ahead and completely virtualizes everything, optimizes it in the virtual world, it all very quickly pays off for the customer. They benefit from fast time to market, a better product, and more efficient use of resources.
Der Vorteil eines Virtualisierungs.
The advantage of a virtualization center is that we determine where problems arise early on. Problems can be corrected and immediately transferred to programming.
In die Programmierung übertragen werden, somit
This shortens the time needed for commissioning on the real-life machine, since this time directly impacts the delivery time for our system.
The interplay between hardware and software will be one of the keys to the digitalization of tomorrow. To do this, we need to provide hardware and software that work together optimally within a framework, the TIA portal. With Bausch and Ströbel, I never get the sense that I'm just the supplier. Instead, it feels like we are partners. We jointly determined that digitalization is the key to remaining successful in the future as well.
What do we think makes a good technology supplier? Outstanding quality, a thoroughly global approach, and great deal of innovative strength, which we see reflected in the products. And I think this is what Siemens represents.
Good afternoon, ladies and gentlemen. My name is Zuili Eclaire, and I am the Assistant Editor at Publish Industry India Private Limited. Publish Industry India is a 100% subsidiary of Publish Industrie Verlag GmbH Germany, and that publishes the trade magazines A&D India, which is Automation and Digitization, and EM, which is Efficient Manufacturing. I will be your host for today's webinar, and it gives me great pleasure to welcome all of you to today's webinar on the new era of industrial machinery engineering with Simcenter, in association with Siemens Digital Industries Software India. So, ladies and gentlemen, engineering tomorrow's advanced production machines requires a new engineering approach. Mechanical, electrical, electronics, and software system performance all must come together and exceed your customers' expectations. Siemens Advanced Simulation and Test Solutions can help you engineer, simulate, and virtually commission advanced machines from concept to validation to in-service deployment. So talking about this today will be Mr. Sushil Samuel, Country Portfolio Development Executive, Siemens Digital Industries Software India, who will today discuss the most significant trends, technologies, and processes that will drive change in machine engineering. So before we begin today's webinar, I would like to tell our audience that at the end of Mr. Samuel's presentation, we'll be open to Q&As. So you can just drop in your Q&As and we'll get them answered by Mr. Samuel. So let's begin. I would like to welcome Mr. Sushil Samuel, Country Portfolio Development Executive, Siemens Digital Industries Software India, to talk about the new era of industrial machinery engineering with Simcenter. So over to you, Mr. Samuel.
Thank you so much, Julie. Hi, everyone, and welcome to this webinar where we will be discussing the manufacturing and production machinery, the performance engineering of those machines. Thank you so much for hosting me, and I know your time is very valuable, so I'm going to get straight to it.
In today's competitive environment, getting better products to market faster is not just desirable, it's essential. Manufacturers need to meet tight development schedules and budgets. While competing for a customer's interest and loyalty, innovation and superior product performance are key. On top of that, many products have evolved into intelligent systems, requiring a radical change in the entire engineering process to allow for systems-driven product development. With the Simcenter Portfolio, Siemens PLM software helps leading automotive companies to develop better performing and safer cars. We help the major aircraft manufacturers engineer the airplanes you travel in. We help the telecom industry by testing the satellites that support the wireless telecom revolution. We ensure better fuel economy, lower emissions, and increased performance for marine vessels. We contribute to more efficient and safer processes in the oil and gas industry, and we help thousands of other customers in other advanced manufacturing industries to create brand value. In this hyper-competitive age, the ability to create innovative designs that address specific market needs and getting them to market faster than anyone else are key factors to sustained growth and long-term success. The Simcenter Portfolio specifically addresses the engineering challenges associated with intelligent systems development. Our state-of-the-art software and hardware are applied to optimize critical engineering attributes, ranging from system dynamics, fluid and thermal performance, structural integrity and sound quality, to durability, safety, and power consumption. Our software, hardware, and services enable radical process change. Our simulation software and innovative testing systems support optimal decision-making all the way from initial concept to final delivery. We offer tailored software and information technology to support this integrated development process. Upfront analysis at the concept stage, virtual simulation to refine and optimize digital twins, and in-depth testing of a reduced number of physical prototypes. Combined with Teamcenter, we provide the platform for a knowledge-based approach, where engineers can collaborate and share information across the extended enterprise and throughout the entire process. Our engineering experts team up with leading manufacturers worldwide to share our latest technology breakthroughs and improve their products and processes. By combining physics-based simulations with insights gained from data analytics, Simcenter solutions help optimize designs and deliver innovations faster and with greater confidence. We help companies deploy a new predictive engineering analytics approach in support of a closed-loop, systems-driven product development. All this enables our customers to deliver unrivaled product performance while significantly cutting time to market. It's moving away from the expensive and ineffective test, analyze, and fix approach to design right first time. For decades, thousands of engineers around the globe counted on us to develop their ideas into top-performing products, and they can keep counting on us for decades to come.
So that was a brief introduction to Simcenter, which is our portfolio of simulation tools. Now, as Julie mentioned, my name is Sushil Alexander Samuel, and these are my coordinates. Do note them down. There's a very good chance, like even if you have particular tools, or there's, let's say there's a gap that you see which you don't think can be bridged, we have a very, very vast portfolio, like from autonomous vehicles to predicting the reliability of a particular system. All these things can be done. They're not solutions that we put upfront because they're very, very niche products, but feel free to reach out if you feel you have anything that needs to be resolved, which even if you feel, I mean, how can it possibly be done? It's very likely that Siemens will have a solution. So do reach out and we'll help you address those issues. Now, moving on to the current trends in industrial machinery. I mean, so I'm sure all of you all are already aware of most of this, so I won't spend too much time on this. But basically, the customization of products is one thing that is very important. The smart manufacturing is another thing that we're looking at. New technologies are coming into manufacturing, like let's say additive manufacturing, etc. And then, of course, global competition from people who are able to reduce their manufacturing costs so much that they are able to give things at such a good price that it's very difficult for other markets to compete. I think we all know who we're talking about here, but all these are the different challenges that the industrial machinery industry faces right now. Now, this is just going further into the details of all these different topics. Now, the problem is the cost of status quo. Now, let's say things are working right now, but and we might not see a need to change. But look at the problems that might crop up 5 years from now, 10 years from now. For example, something like Hindustan Motors, the makers of the Ambassador, they kind of refuse to adapt. And now where are they? A similar situation happened with Nokia. So it is always important that we need to meet whatever is happening in the industry. We need to be able to address those. We can either disrupt or get disrupted. So that is the challenge before all of us today. Now, digital transformation is the main reason just over half of the companies on the Fortune 500 have disappeared since the year 2000. Now, this was something that was mentioned by the Accenture CEO. Now, that's may not be an area that most of us are involved in, but a lot of this digitalization, it's touching multiple industries. Now, even build-to-print manufacturers who were getting the designs from the customer and just kind of manufacturing to those specifications, now slowly OEMs are starting to ask for more from their suppliers, asking them to do a little bit of the validation and validation upfront. So then the amount of work on the OEM kind of reduces. So this is a trend that we see the industry is moving towards.
Digitalization changes everything. The world around us is changing due to an exponential growth of technology. And digitalization benefits are not only reserved for the happy few bigger enterprises. I am here to tell you that it brings added value to a wide range of companies in various sizes. Every enterprise is unique, and so there is no one-size-fits-all solution. Market demands are changing rapidly. On average, we could say that there is a higher need for development speed, call it the from ID to shelf time, for flexibility as a result of the increased personalization of products, for quality as a key differentiator, and for efficiency, meaning energy, equipment, and resource efficiency. Let's have a look at a tangible example. This machine has been built by Delta Application Techniques. Its main task is to perform quality tests on bottles before filling them. The key performance indicator is simple: achieving the highest possible throughput rate. When introducing a completely new machine, manufacturers want to be sure that its design is feasible and performs its tasks, so they can validate the concepts they have in mind up front, together with their customers. This is a major differentiator in the pre-sales phase. The Siemens digital twin concept provides the answers to those challenges. A digital twin is essentially a digital copy of the machine. It is an intelligent and dynamic virtual model in which mechatronic and kinematics behavior is included. Most of the engineering tools incorporate simulation functions for validation purposes. However, connecting these tools with the automation software and controllers provides the real benefit. This approach reduces the need for physical prototypes significantly. Think about some of the things you can do virtually. You can reduce factory acceptance time through virtual commissioning. You can guarantee fast and accurate maintenance support. You can even start training operators before delivery. To improve an existing machine, we systematically look for the bottlenecks in the as-is configuration. Using a multi-physics model, alternative scenarios are explored to enhance performance. Physical testing is required in order to validate and improve the model and its parameters continuously. By the way, models are not only used during design, planning, and engineering phases. They are also of vital importance during operation and service. The digital twin touches the entire value chain and represents the product, production, and performance used for validation of the real-time machine. Critical production parameters and machine statuses can be managed in MindSphere, the Siemens cloud-based ecosystem, providing performance data and analytics. So, don't wait and implement now. Digitalization started yesterday.
So that was a brief insight into how Siemens handles the entire digital twin. Now, this is not just the performance engineering bit, it's also the manufacturing, it's also, as I mentioned, the cloud aspect of it. Now, why do you require things like the cloud? Now, we'll come to that. So now there are three phases of the digital twin. The first is the ideation, where you are creating the product. You have a concept, you create the parameters, then you go into detailed 3D design, then you start your simulations on it, then you do your physical testing. Once the prototype is fully tested, you move on to the realization phase. This is where you go into the manufacturing. You're going to lay out the entire manufacturing plant, do virtual commissioning to save time on the actual physical commissioning of the plant. And then later, when the product actually goes into the field, you can get insights from the usage of the particular product. Like let's say the vibrations happening in a pump are very high. So you can monitor, as the supplier, you can monitor that and actually tell the customer like, okay, now it's maybe time to replace this particular part, maybe redo the entire, get an entirely new product. Another way that this can be used, this utilization phase of collecting data. So now all these products are now connected to the cloud. So that is how they are feeding the data back to you. Now, in terms of a warranty, like let's say a person comes back with a claim that, okay, this thing is not working, but then there was a measured impact to the particular product. So that which actually, let's say the product was dropped. So that actually voids the warranty. So you've already got that measurement from things. So immediately you can invalidate the warranty on that particular product. So all these things are very, very useful to monitor the usage of the product in the field. Now, Siemens is the only one who can handle all these three aspects of this digital twin. Now, when we're talking about performance engineering, it's exclusively the design and the R&D phase of the product design. Now, here we need things like realism, where earlier it used to be very simple then we moved on to the approximation slowly, and now it's actually real life physics that we are looking at. The continuity earlier, everything was very, very siloed. And then when people realized it was being siloed, let's say the structural was in one team, the CFD was in another team, and they were kind of operating in their own worlds. Then slowly people put together a system where there was a certain amount of communication happening between the two. But now we're moving to a phase where the data automatically flows between all these teams, like from design to the simulation team, everything. And this is one place that, again, PLM can really help. And then you have a certain design space that you are looking at. Like, let's say for a particular product, you have certain design variables. Now, we know from a rule of thumb, we've possibly been designing the particular products for years together. As a rule of thumb, we know, okay, what's going to work. But there may be certain options which we haven't even considered. Now, initially, this exploration is just where we feel, okay, yeah, this might happen. Now, then the next step is, okay, we have these variables, iterate through all of them. Just automate the entire process and iterate through everything. And then there's an intelligent exploration where we actually, we're not actually mindlessly iterating through the different variables. This isn't the Rangekutta method we learned in third sem of engineering. This is actually, let's say, one particular variable is taking the design objective in the wrong direction. Okay, let's stop iterating through that. So now we have a patented algorithm here. Now, this is something that we will come to later. But for now, this is a much, much faster method than just simple automation. Now, when we have all these things in place, that's when we get actual productivity and we can save on the engineering time. And it allows the engineers to do what they actually can do, which is innovate. Now, like I mentioned earlier, we have three phases. One is where we're ideating, one where we're looking at the realization, and the third one where we're looking at the utilization in the field. Now, all these different stages feed insights come to the other stages. So that way you can continuously improve the entire process from the product concept to the utilization in the field. Now, this video showcases how Siemens tools can be used as a platform to fully implement the digital actual live customer use.
My name is Jan-Willem Ridderinkhoff. I work for the engineering department of a company called PM Bearings. And at PM Bearings, we make motion components ranging from the single bearing components, linear bearings mostly, up to fully integrated motion systems. And we do that mainly for the industries in the semiconductor application and in the medical industry. Our customers are demanding very short time to market, and for that we need a really good efficiency in our way of working. So the Siemens software helps us with that, to get the product from design up to delivery in a really short cycle time. Yeah, the Siemens PLM software we are using are the Teamcenter package. So we use that to combine all the different packages that we use, and those packages are the NX-CAD environment. We also use the NX-CAM environment, and we use the Simcenter environment to make all the analysis of the parts that we design.
GARS PLM Solutions is a platinum partner for Siemens PLM software, and our goal is to enable customers to make the best product by implementing the right software they need. Regarding the relationship with PM Bearings, it's a real strong partnership for several years already, and we use our expertise to help them implement the right software they need to digitalize their design, engineering and manufacturing process.
GARS PLM Solutions helps us with setting up our installed database and also with all the other applications. So we have a very tight collaboration with them.
Ik ben verantwoordelijk voor het omzetten van klantvragen, eisen, wensen naar een goed design. Ja, de uitdagingen zijn heel uiteenlopend. Dat kan zijn van hele hoge nauwkeurigheden tot omgevingen waar je aan moet denken, dus cleanroom-omgevingen of dat soort zaken. Maar het kan ook te maken hebben met bepaalde materialen die niet gebruikt mogen worden. Dan kun je denken aan niet magnetisch of het moet opereren in ultra hoog vacuüm. Ja, om deze uitdagingen op te lossen gebruiken we NX-CAD. Dit pakket gebruiken we om modellen uit te werken. Ja, hiermee kun je bepaalde doorsneden maken, je model goed analyseren. Maar we gebruiken het ook om werktekeningen te maken. Wat ik dagelijks gebruik is de interactie met Teamcenter. Zodat je altijd makkelijk bij je producten kunt. Een groot voordeel daarvan is dat je ook je attributes kunt vullen. Dus bij elk onderdeel kun je attributes aan het onderdeel hangen. Dat is een grote pre voor werkvoorbereiding.
Well, I think the biggest challenge for me is to make accurate simulations in a short time frame. The difficulty with bearings regarding the stiffness, they're geometrically nonlinear. For example, if you push a roller into a track, the contact surface increases, which stiffens up the bearing. So taking this geometric nonlinearity into account, well, that is what I do with the software. There is no need to export the model to a separate FEA module. I can do all computations just within the Simcenter module.
Nou, we gebruiken hier NX-CAM en dat helpt mij heel erg ter ondersteuning met alle features die er zitten om tot een juiste oplossing te komen voor elk probleem. De belangrijkste feature op dit moment vind ik wel de 3D-simulatie. Die is grafisch heel sterk. Elke fout komt heel duidelijk aan het licht. En dat is wel echt een groot pluspunt. Het scheelt gewoon, ik denk 80% van de tijd.
What we achieve by using the software of Siemens is that we get the whole company connected to each other. Everybody benefits, for example, from using Teamcenter. So people can visualize the designs that our CAD engineers make. People can also get all the ordering information out of Teamcenter. The CAD engineer can directly get his CAD model to the CAE engineer. So he can make the analysis of the parts. Also can make adjustments to that if necessary and redo the analysis. And then feed that back to the CAD engineer again. And once we release the design, the CAM engineer can get it directly out of Teamcenter. He can make all the programs for the milling machines and send those directly to the machines. So in the end, we gain a lot of efficiency by using the whole Siemens package.
So that was an example of how all the Siemens tools like NX-CAD, which is our CAD package, Teamcenter, Simcenter, NX-CAM, which is meant for manufacturing, everything is being used together as one entire platform for the enterprise. Now we'll just come to a quick poll question that Julie will take over for. Julie.
Yes, so can we please have the poll? So you have the poll on your screen. The question is, how often do you develop new products variants? Your options are less than 6 months, 6 months to 1 year, 1 to 2 years, or less than 2 years, and 1 to 3 years. So you have 10 seconds to vote, so please vote. All right, so I think we can request Mr. Samuel to please carry on with the presentation. And thank you, ladies and gentlemen, for voting. Mr. Samuel, back to you.
Every innovation begins with a dream. But in this age of intelligent products, it's more difficult to get that dream off the ground. Engineering in this age requires a new approach, one that's more integrated and can better predict product performance. Introducing Simcenter from Siemens. Simcenter helps you create a digital twin that accurately simulates product performance from concept through end use. This is predictive engineering analytics. Begin with 1D simulations to optimize system performance based on requirements. Then, integrate multi-discipline 3D simulations to ensure structural integrity. A quiet cabin. A smooth takeoff. Improved aerodynamics. And more. Combine simulation, physical testing, and data analytics to explore new concepts. Go beyond verification. Simcenter, predictive engineering analytics to deliver innovation sooner and with more confidence than ever before, so your dream can take flight. That's ingenuity for life.
Mr. Samuel, I think you're on mute. I mean, are you saying anything?
Oh, sorry, Julie. Yes, I was actually talking, but I got to unmute. Yeah.
Yeah.
So this is basically so we'll go through a couple of case studies now, and I won't spend too much time on these case studies because they'll cater to only particular segments. But if you feel that there's something that is relevant to you, do feel free to reach out, because we have a lot of such case studies. I've just picked a few from each industry. So if you want more details, if you would like a presentation or demo, we'd be happy to work with you. So do reach out on the coordinates I shared earlier. I'll also be sharing it at the end of the presentation. Now, in this particular case, this was the ceramic kilns of SACME were optimized to use 10% less methane for their ceramic kilns. Next, we have Picanol, who basically textile machinery manufacturers. Now, they were able to optimize their looms. Now, this is for machine tools. They were already doing a certain amount of simulation, and we managed to reduce their simulation time by 50% using Simcenter. Now, here again, there's a combination of, here you can see the, let me just switch. You can see the data acquisition system where earlier we used, people used to use like bench mounted racks for measurement of all these vibration data. Now it's just a handheld device, which is so tiny, which you can even use in the comfort of your office, an air-conditioned office. And you can monitor everything that's happening in the field. Similarly, again, the liquid-cooled nozzles for cutting tools by Mitsubishi Materials Corporation. Here, we managed to get a 40% better time, the cycle time, useful period of the particular, the liquid-cooled nozzle. Now, how do we do all this? So now we move to Simcenter, which is our entire, it's like a umbrella. Simcenter is basically a brand under which we have multiple tools. Now, like I mentioned earlier, right from a basic structural to looking at autonomous vehicles, or let's say designing the new age batteries with the latest battery technologies, the all solid state batteries, that also we have the simulation tools. It's very hard to get that kind of expertise right now, even in India. It's a very, very niche thing, but we already support that with our tools. Now we can cover all the mechanical aspects, we can cover the fluid and thermal aspects, anything related to electronics we can handle. Physical testing can be done, system simulation, which is done right from generating the parameters up to the hardware and loop stage, everything can be done. Now, over and above all this, we have the exploration and analytics, which I mentioned, the design space that we explore. I'll come to that a little bit later. Automation of the workflow, which a lot of people still look at because they may use so many different tools. Now, let's say you're using some other simulation tools already, and you want to automate your entire process. Again, that is something that we can do. We can link up all these different tools and automate the entire process. Now, process and data management, again, will come from a tool, which is Simcenter. Now, over and above all this, we have engineering services, which, let's say you currently don't have the skill set to use a particular set of tools. They will do the development, and then they can do a technology transfer, or they can like work out a new methods for your simulation team, or they could also co-develop with you. So there are multiple approaches that engineering services take. It's completely up to you what you want to do. And I must mention this dedicated support that Simcenter offers. So it's not like the support that you get with Airtel, where you have to call up a call center and someone just reads out from a fixed set of responses. Here, there's actually a PhD, a person holding a PhD who will come sit down with you and explain how the tool will work for your particular processes. And let's say there's a particular feature that you feel is not there at the moment, they can put in a request for that. And we have a cycle time, a release cycle of 3 times a year. So that feature will come out as soon as possible. Now, let's say someone else has requested a feature which has come out recently, which the dedicated support engineer feels that would be relevant to you. He will again come sit down with you and tell you how this particular feature is going to add value to your process. So it's a very, very involved form of support. Now, basically, Simcenter enables you to model the complexity of the modern products, to explore the different possibilities within those products, to do all this faster, which is the biggest thing that we need to keep in mind through this entire thing, to minimize cost and effort and time. And then also staying integrated through all these different activities. Like, we don't want everything to be siloed, like structures in one place, CFD in one place, the multi-body dynamics simulation happening in another place, durability happening in another place. Everything, we want it happening in one place. Now, that is one place that Simcenter really shines. It gives you better products, higher ROI, greater productivity, and faster innovation, and insights much earlier in the design process. Now, this is the typical design process where you start with the system, you start designing the system, then you do the subsystem, then you do the components. Then same way you start, once it's been prototyped, you do it for the component, you do it at the subsystem level and then at the system level. Now, this has to cut across all the different areas of the mechanical aspects, the electronics aspect, and the software aspect. Now, the design, whether it's NXCAD or some other computation tools, Teamcenter, which handles a PLM across this entire information management, across this entire thing. And then the Simcenter, which also works in all these different phases. Now, Simcenter, the system modeling aspect, system engineering, we have this tool called MSIM, which currently there's no other tool like this in the market. So basically, it has a huge library of industry validated components. You just drag and drop, put the particular parameters, and it runs a very quick simulation, maximum 5 minutes for some simulation like this. Here, it has very, very basic visualization. It's not meant as a visualization tool because we haven't gotten to the 3D design yet. So this can be used for, we have all the different libraries here. We have, you can use, validate any control system that you have. You can plug in MATLAB or something like that. You can use plug in a prototype directly to do the co-simulation with the rest of the system. So one place this is used is for something called fly it before you build it, which is where you can actually fly a plane before you actually even go into the first physical prototype. So it is at that level. You can actually ensure that it'll meet the certification standards after the entire design process is done. So you're doing that at this stage itself. You haven't even designed a single 3D model. So this is extremely powerful. So, and it's something that a lot of people currently aren't into. So if you would like more details, do get back to us on this.
In this example, we want to show you how system simulation with Simcenter MSIM can improve your robot development process. Therefore, in a first step, the simulation model of an individual leg is developed. It consists of the leg made up of components from the 3D mechanical library, 3 DC motors to drive the hip, thigh and lower leg joints, and 3 controllers to control the individual joint angles. With MSIM's 3D assembly tool, it is easy to visualize and position the different body parts, as shown here for the thigh, which is connected to the hip and lower leg joint. The same tool also allows us to animate the leg movement from different perspectives. Once we are satisfied with the leg movement, we can continue with step 2, the body assembly and control development. MSIM allows us to speed up this process by reusing the leg model 4 times and connecting it to a body. On the bottom of the model, you can see the control laws for the leg movement to perform different body movements. In order to visualize the robot movement, we can add cameras in the animation space and also make use of a split screen feature. Let's perform a 20-second long simulation run and see how our robot behaves. First, we check if the controllers behave as required and if the set values are met. In the animation, we can see that the robot initially performs 2 push-up movements before it starts walking. Since it's not really walking in a straight line, we can now start to optimize our control laws. For further information, please get in touch with us.
So that was an insight into how to use system simulation. Now we move on to the mechanical aspect, where here we have all the different physics, like it could be durability, it could be acoustics, it could be structural, thermal, flow, additive manufacturing, electromagnetics, material, microstructural material analysis, everything in one single environment. Now in this environment, the single environment is called Simcenter 3D. You can do all these different kinds of analysis. You just need to mesh one model and the rest will be handled by the tool. So there's no creation of multiple tools for multiple solvers. It's very, very streamlined. Right. So that was basically Simcenter 3D, how it's being used for motors. And you're doing the electromagnetics, you're doing structural durability, everything within that same environment. And in the backend, we use multiple solvers. One of them is Simcenter NASTRAN, which a lot of people are not aware, but MSc also has so this was an open source thing from NASA. So MSc acquired it, and so did Siemens. So we have the same tool working in the backend. And we also have multiple other solvers like SAMCEF. And then we use Magnet for the low frequency electromagnetics, Galileo for high frequency electromagnetics, Multimech for the multi-scale material simulations that I had spoken about earlier. So all these different solvers are called in the backend as and when required for the particular application. Now I'll just skip this video. Now, again, this is a low frequency electromagnetics tool. I won't spend too much time here because we like to spend a little bit of time on Q&A as well. So, so this is Simcenter Magnet. It's used for basically all the low frequency, all the actuators, the design. This is Simcenter Speed. It is used for motor design. Similarly, we have MotorSolve, which is also used for motor design. It came in through a different acquisition. Both of them have their independent strengths, but these two tools are being merged together. Then we come to the fluid and thermal aspect. Here we have Flow EFD, which embeds in any CAD packages. So irrespective of whether you're using CATIA, whether you're using Creo, whether you're using NX, it'll embed in all of them, and you can do basic simulation there, CFD simulations there itself. So you can do upfront validations. The designer itself can do upfront validation. For example, let's say a mirror on a car might as well be a rectangle to a design, to a CAD person, but there's a very high drag coefficient. It's very bad for the aerodynamics of the car. So now they can do upfront simulations to ensure that a certain criteria is met, and then they can move it on further to the design team, to the R&D team, which saves a lot of time in the design iterations. This is StarCCM, which is our flagship CFD solver. Can handle multiple different kind of physics.
Why do people use software?
So
to save
I won't
costs,
spend too much time on all these.
Quicker. I think if you do not do simulations,
you can always
to the old way.
There on our website as well, so you can take a deeper look at all of them. Then looking at the electronics from EMI, EMC perspective, you could be looking at the, like I mentioned, the low frequency. You could be looking at the high frequency, like antennas and towers and things like that. All these things we can handle within Simcenter 3D itself. Then physical testing. Here we can measure all the data. Now, Siemens is the only vendor that can offer both the physical testing and the virtual validation. So let's say for we want to check the vibrations that are coming on a particular axle of a vehicle. Now, normally we just assume that and just kind of use a rule of thumb, and we just go ahead with a simulation. But very often that could be incorrect. So like they say, junk in, junk out. So we need to actually measure those things. So for that, you can mount the testing setup, and then you can use the actual values to do your simulation. And for example, if you're doing a modal simulation, after that you get a particular natural frequency, you make a prototype, but then when you measure it, maybe let's say the material characteristics that were input were a little off. So the test, whatever was measured from the test setup, can be used to correlate with the the FE test correlation happens, and your simulation model is now a high fidelity model. Now you can go ahead with your simulations on that model to ensure, you know that it's 100% accurate going forward from there. So, which is something that is very, very vital in simulation, because the simulation results are only as accurate as the inputs that you have provided.
To keep up with customer demand, engineers need to continuously optimize the functional performance of their designs. At the same time, they need to take attributes like noise levels, energy consumption, durability performance, and comfort into account. A quick fix focusing on just one of these aspects will almost always introduce new issues elsewhere in the design, as they are all interlinked. To master this complexity, to balance the various attributes, and to get to the root cause of noise and vibration issues, Siemens PLM software has developed the Source Transfer Receiver methodology. What we do is to clearly separate the origin of the noise and vibration problem from the way it is propagated through the structure and onto the receiver. Let's apply this method to a CNC machine. The accuracy of the milling is crucial, while also the production speed needs to be maximized and the energy consumption and tool wear needs to be kept under control. For example, simply increasing the production speed might lead to higher vibrations that affect the accuracy of drilling. Balancing all these attributes is certainly not easy and requires a systematic approach. In this case, we primarily consider the balance between production speed, cost, including energy efficiency, downtime, and tooling wear, and finally, quality. Applying the source transfer receiver model to this example, the source is the contact force between rotating tool and the workpiece as well as the engine. The frame and tooling head are the transfer paths through which the vibration energy travels through the machine. The receiver in this case is the material to be milled. Speeding up the engine may result in increased vibration levels, which impact the surface finishing, tool wear, and potentially reliability. It is important to consider all sources and all transfer elements. We identify the frequencies generated by the source in different operating conditions, as well as the natural resonant frequencies of the transfer paths. Problems occur when these frequencies coincide. Now we have an accurate and complete insight in the vibration phenomena. This is what we call system characterization. Now we can start solving the problems. On the source side, we can replace the engine with a different model, or change the operating speed. Alternatively, the transfer paths can be stiffened to move the resonant frequency, or damping can be added to reduce vibration levels. This methodology can be applied in a troubleshooting mode, but ideally it is used as soon as possible in the product development cycle to design right first time. It can be used in all product development dealing with noise and vibration issues like cars, aircraft, ships, white goods, heavy equipment, etc. The Simcenter Portfolio offers all the required tools and services to support the source transfer receiver approach. Thanks for watching. Please visit the website for more information.
So now we come to Test Lab, which again is the our testing solutions. Now, again, I won't go into too much detail here. I'll skip this video also. It's also a view of how the testing setup is used. Then similarly for electronics, so we need to characterize the thermal performance, because thermal runaway is the single biggest source of electronic failures. So now for all the different electronic components, you can thermally characterize them, and even you can go to the detail of when you put a chip on a PCB, you use a certain paste to fix it to the PCB. You can even characterize the conductivity of that particular layer of paste. So everything is covered within this Simcenter Mechanical, which is completely geared towards electronics testing. Exploration and analytics, this is where I was talking about how we can actually make a huge difference with Siemens. Now, earlier we used to start with an objective X in mind and modify certain design variables, right, to reach this objective X. Now the entire concept is turned on its head by this design space exploration. Your first criteria here is not the variables, it is the objective. And then you can mention which variables have to be iterated through. And even your objective you could have multiple objectives, like multiple disciplines. So it could be one in structural, let's say the stiffness shouldn't go below a certain value. The temperature should not exceed a certain value, which is the case with this particular simulation that you saw here. Now all this is done in one particular tool, which links all your individual solvers or CAD packages, everything is done within a closed environment. And you can also specify certain constraints, like let's say the fan needs to have a certain number of blades only. You can't change the number of fan blades, whatever the reason. So it'll ensure that it changes all these variables without violating the constraints that you've mentioned to achieve those objectives that you've specified. And you can even specify the significance of these particular objectives. Like let's say the temperature is 75% importance and the stiffness is 25% importance. So all these things it'll balance all these different attributes to give you the best possible output. So this is something that is the algorithm for this is a Sherpa algorithm, which is proprietary to Siemens. So again, do reach out if you need more information on this. Then process and data management simulation tends to generate a lot of data. So we need to maintain all that properly so that streamline the workflows and everything. So this is done with Teamcenter. So this is over and above Simcenter and all the other processes, covers of manufacturing, everything. Now, where we were talking about HEADS, similarly, some people just want their workflow to be automated. So we can actually do that. This is just a unit of HEADS. So the optimization algorithm is taken out. It's just the automation part. And engineering services I spoke about earlier, so I won't spend dedicated support again. We talked about. Now, one thing, like certain vendors in the market are, their tools are no more in development. That way, Siemens is completely committed to this area. We have a lot of investment in this area, 5.2 billion in the last couple of years. We have a lot of software developers working on it. We have patents, we have everything that's happening. So 92% of Fortune 500 industrial companies are our customers. So basically what we're saying is once you are on our platform, you will never be left out in the cold. We will always be there to support you. And to build the thing, it's been both organic and inorganic growth. We've acquired multiple companies over the years, starting from 2007 onwards. So any place we feel there's a gap in our portfolio, immediately we kind of bridge that gap to ensure that none of our customers have an issue and need to move to other platforms. All those solutions are available within one single platform. Now, basically, Simcenter acknowledges and addresses all the different new technology trends, from whether it's the generative engineering, digital twin, additive manufacturing, autonomous vehicles, materials engineering, 5G, front loading of simulation, which is something that we do again with the Flow EFD that I mentioned earlier. Now, to support this entire thing, we have this thing called the accelerator portfolio, which is handled by Siemens, and there are multiple SaaS offerings also. So again, do reach out to if you want to look at any of these areas: mechanical, electronic, simulation, manufacturing, operations, IoT, analytics, applications, collaboration, everything we can address. Now we'll just pause for a short question by Julie again. Julie, over to you.
Yes, so we would like to have our second poll question for our audience today. So can we have the poll on our screen?
Julie, I think you're muted.
Sorry. Yes. So your poll question is, what benefits do you foresee by performing product validations virtually in your organization? Your options are saving time, saving cost, saving effort, increase in quality, or all of the above. So you have 10 seconds to vote. So please do vote. Also, ladies and gentlemen, while you're voting, I would like to tell you that please put your questions in the Q&A box so that we can see your questions and we don't miss out on any questions. So don't put them in the chat box, put them in the Q&A box so that we can address your questions to Mr. Samuel. All right, so thank you, ladies and gentlemen, for voting. And now we will be giving the platform back to Mr. Sushil to please continue with his presentation. So Mr. Sushil, over to you again.
Yeah, thank you, Julie. So this is a few of the investment focus areas for Simcenter. We want to increase the customer's confidence in the simulations that he's done. Like, we don't want it to be junk in, junk out. We want to give the most accurate thing. So we have multi-physics, multi-fidelity. We have industry expertise within a pre-sales and services organization. We work with enterprise. We enable enterprise collaboration by being very open. So it's not like if you don't have NX CAD, you can't use Simcenter. You can use whatever CAD package you have. You can still use Simcenter. All our tools work with any inputs, and you can output them to any other platform also. Like, let's say you're more comfortable with some other tool which you've been working for many years. All that is all fine, because we're all, it's architected in such a way that it's open and scalable to all these different tools. Then also, like I mentioned, we delivering insight over and above what is normally done in simulation. Like, you can realize with heats, one thing you can do is realize the sensitivities of different variables to the final objective that you have. So you can see what varying this variable does, what changing another variable, how it's affecting this variable, and all these different design sensitivities can be arrived at using Simcenter. Now, again, saving engineering time and accelerating the return on investment is one of the, it's the single biggest objective of any company. So the ease of use also is something that we look at here. So this is something that we are very, eventually a lot of these tools, they're all solving the same equations. But what really makes a difference is the ease of use and the user experiences and the support if there's any issues. So that is something, again, where Siemens is investing big time. And the deployment flexibility, whether it's on-prem, whether it's on cloud, everything, we allow you all to do everything. So now Simcenter basically looks at the these four different aspects that we see in machinery performance: reliability, the smarter machines, and efficiency. Now, cutting across this, you have exploration analytics, and you have data and process management. Now, coming to performance, you look at things like throughput, production rate, precision, accuracy. This is a video case study. I won't spend much time here because I think we're running out of time now. This is, again, a packaging system where they were looking at they wanted to optimize the entire product quality. So you can see they're looking at the different flow nozzles. Similarly, in the case of extrusion, here again, we can Battlefield Cincinnati was able to actually improve their processes. They were able to save on the raw material that was used and also electricity. Then we look at reliability. Here we have durability, maintenance, electromagnetic, EMI, EMC, noise, vibration, thermal, multiple aspects to look at. Again, this is a video case study. Due to the lack of time, I won't go through it. HOMAG, this is for milling machines that it was used. they were able to reduce cost and time. Pick and all, again, which we discussed earlier. This was a slightly different, I mean, they're extensive users of Siemens tools. So this is another case study, but they were able to use it in a different way. Now, this is for electromagnetics modeling. This is in the case of low frequency electromagnetics. Now, they basically simulated the operation of a device based on the electromagnetics or purely electric fields. Now, here, these particular use cases are, we can't really divulge the customer name because it's we have NDAs with them, but which is why you just see the details of things. So this was low frequency, this is high frequency where it's been used. So again, all these different use cases that you see, if you feel that you require, you want to know more about, let's say, textile machinery or the milling machines or motors, high frequency, low frequency, electromagnetics, do reach out and we will get back to you with more details. Now we're looking at smarter machines. So here we're looking at the controls, we look at flexibility, operator assistance, predictive maintenance, and IoT. So this is basically a Raunchy Mario, which is bottling things. So now they reduced the number of prototypes by more than 20%, and they saved weeks in terms of. Now this again was completely done with MSIM, which is the system simulation tool. And lastly, we come to efficiency. So here we look at things like energy, tool wear, waste, etc. Again, video case studies, so I won't spend time on this. Pick and all, again, they managed to make something. Again, these are all extensive users of our products. So they managed to increase the productivity of their weaving machines by about 15%. Now we come to our last poll question, and after which we will have probably, I think, 4 slides to run through, and then we will reach the end of our presentation and we will take up all the questions in the Q&A session. Julie, over to you for the last poll question.
Yes. So ladies and gentlemen, we have the final poll question for all of you. So can we please have the poll on our screen? Yes. Does your organization currently use virtual validation or simulation? Your options are in-house usage, simulation outsourced, only CAD, or no design or simulation. So you have 10 seconds to vote, so please do vote. All right, so thank you so much for voting, audience. I would like to hand over back to Mr. Samuel. So Mr. Samuel, back to you.
Thanks, Julie. Yeah, so like I mentioned earlier about engineering services, there are different ways that they will engage with you. One is, let's say in your process, you have certain things you've come across, they will do the troubleshooting, or they will develop along with you, or they will do the development themselves and then do the technology transfer for you. Or let's say you already have a team in place, they will rejig your entire methods, the methods that you follow to achieve the maximum efficiency. Now, we have skill sets in NVH, durability, efficiency, speed, mechatronics, CFD, controls, etc. So anytime, even if, let's say some of these tools may have seemed a little too complex, we can always work with you and get you up to speed to give you that cutting edge advantage in the industry. So again, the Simcenter portfolio gives you that realism, the continuity and exploration to enable the productivity of your team. And they can actually get innovative solutions. They can do it faster to market. The products are better, cost is lower, and the market agility is much, much higher. Now, how do we do all this? Now, this is something that we've done multiple times. So you have a particular innovation goal. Now we'll start with a particular project just to, as a curtain raiser kind of a thing. And then slowly we go into the digital prototyping, digital product prototype. Then we do the exploration and analytics on that. Then you have a better performing design on your initial design. And now you start extend, so that becomes your first success. Now you start extending it to multiple other projects. And then you have the goal, you reach your goal of being able to innovate through your entire process. Now, today, maybe we just need to start with this first project identification. Just identify that, come to us, we will help you completely change the way you approach product development. So in summary, to master this complexity, you need solutions that help you drive innovation. They enable collaboration by breaking down the different silos and weaving this digital thread across all the development activities with a comprehensive portfolio that combines simulation and test, along with engineering services and support, and backed by the strength of Siemens and Accelerator. And Siemens offers this unique DNA which can help you in your digital journey. So thank you everyone for listening so patiently. I know I've overshot a little bit, but do feel free to reach out. Any further details you want. These are my coordinates. You can always get back and let me know if you require anything, and we will be glad to support you in your digital journey. Thank you so much, everyone. Julie, over to you.
Thank you so much, Mr. Sushil, for that very excellent presentation and addressed your audience. I'm sure our audience had a lot to learn about Simcenter from Siemens. So yes, we do have a few questions for you. One question that we have is, how can I monitor environmental conditions during pass-by testing?
Monitoring environmental conditions. So this is something that environmental conditions typically is not something that we monitor in the, I'm assuming you're talking about the pass-by noise of a tire or something like that. So in that case, the environmental conditions aren't something that we look at too significantly because they don't have too much of an impact on the eventual output. But if you actually do want to do that, we do have solutions for that. Like, let's say you want to look at the ambient noise. In one of the videos, I think you would have seen a particular test setup that looked like something like a sun. So that is called the sound camera. It's used for larger things like factories and things like that. But in this case, you can isolate places in your environment where noises are coming from. Like in front of the sound camera, if you talk, immediately it shows you a contour map. And the red area is near your mouth. So that's where the vibrations are coming from. So similarly, you can use it in a bigger setup, like in the environment of where you're doing the pass-by noise. So you can quickly eliminate all the sources of the extra noise that might come into the entire process. Yes, Julia.
All right.
To the next question.
Yes. So the next question we have is that in Simcenter Test Lab Navigator, is it possible to find data from multiple folders at once?
Multiple folders?
Yeah.
I'm not sure what exactly.
Okay, maybe we can take this question offline then.
Sure, sure.
I'll move on to the next question. How will Simcenter help me achieve NVH performance?
Okay, so here with NVH, there's both the physical and the virtual aspects, right? So now Siemens offers both the physical testing and the NVH aspect. Now, in the background, again, Siemens, a lot of you may be aware of sys noise, which was an industry benchmark a while back. Now that has been integrated into the backend of Simcenter. Now we can do that simulation in-house within Simcenter 3D, and I can actually use the test setup to measure my inputs, measure the vibrations that are going to be acting on my product. Now I can use those inputs as inputs in my Simcenter simulation model, as they can be the boundary conditions. Now, next, what I can do is, after I finish my simulation, for example, if I'm doing a model analysis, then I get a certain resonant frequency. Now, that particular frequency, when I prototype, I'm not getting that same resonant frequency. There's a slight deviation. That could be because of multiple reasons, like one of them being maybe the material characteristics weren't right. Now, those characteristics would have been measured during your test run. Now, those values can be used to calibrate your simulation model. And now you have this high fidelity simulation model, which you know everything, including your material characteristics, everything is exactly how it should be. Now you can go further doing all your other simulations, knowing that this is now a high fidelity model. So your simulations are going to be 100% accurate going forward, irrespective of what domain you're looking at. So this is one place Siemens Acoustics is actually far ahead of any other acoustics tool in the market, with both physical and virtual validation.
All right, all right. Our next question is that, can you tell us something about HEEDS, H-E-E-D-S? I believe that's the software package by Siemens. So can you tell us a bit about that?
Right. So HEEDS is, so it's not a physics-based tool as such. It's more mathematics-based. Basically, it's even being used by the big four of consulting work for financial modeling. Basically, they just use Excel, which incidentally is one of the inputs, one of the tools that you can incorporate for inputs. Now, HEEDS basically what it does is, now I could have multiple tools, like let's say I have CAD. Then for structural, let's say I use ANSYS, or for MBD I use MSc Adams. For something for electromagnetics I use Siemens Magnet, Simcenter 3D. Now I can actually link all these three things, all these tools together, including the CAD models, and I can iterate through multiple different designs. So let me just quickly go back to the HEEDS. So you can all these different tools start talking to HEEDS, and HEEDS is the manager between all these different tools. So it decides like, okay, I'm changing this particular variable, okay, but it's having a negative effect on the eventual objective that I'm looking at. So then it'll give that particular design variable, it'll put it in the backseat. So now there are multiple different tools like that where you can understand all these different aspects of the now here this is the HEEDS. Yeah, so here this was a particular case where there was a design variables were the positioning of these vents, the positioning of this fan. The more design variables were the number of pins, the geometry of the pins. So now all these things are being iterated through to ensure that there's as little temperature as possible. Now, if you see the last thing where it ends up, there'll be hardly any temperature. There's no red here anymore. So this is the most optimal thing. Now, doing this through in a manual process will take a very, very, very long time. But this could be done in, you could have like 50 simulations done in a night. Now, basically a CFD simulation, so it is very expensive on the resources, but you're not doing unnecessary simulations because you're using the optimization algorithm that is built into HEEDS. Now, again, if this is something that you would like more information on, we can do a deep dive for you, and we can actually provide more details on this.
All right. Now, you spoke about leveraging test data. So another question we have is related to that, how exactly do you do that? How do you exactly, leverage test data? And can legacy test data also be used?
Right. So the test data, similar to what I mentioned earlier, how we can use it for the acoustics and things like that, that's one way we can use it. One thing, which is a fairly recent development, we can use your legacy test data. Let's say you've been measuring these different things for years.
Mr. Sushil, we lost you. We can't hear you. Mr. Sushil? Can you hear me? I think we lost Mr. Sushil. Mr. Sushil, maybe you can log out and log in again so that we can hear you. Yes, so let's just wait for Mr. Sushil to come back. I believe he will be with us in a moment. Yes, he's back. Mr. Sushil, can you hear me now? Can you?
Yes. Yeah. So till where did you hear? I wasn't aware that I had dropped off, so I was
Not
stopped.
much. You just spoke. We didn't. There wasn't much that you covered before we lost you. So yeah.
Okay. Yeah. So could you repeat that question?
Yeah, I can. So I had. So we were talking about leveraging test data. So how exactly do you do that? And can legacy test data also be used? Was the question.
Right. So here I mentioned earlier that how we use the testing for the acoustics and different things like that, acoustics, durability, MBD, etc. But one thing, it's interesting that you brought up legacy data because a new advancement is neural networks. Now, this is a capability that is there within Simcenter MSIM, where we can actually use all that legacy test data. We may have been measuring testing data for years together. Now, I'm not saying that we can use everything that you have, but if there's certain relevant data, we can actually use that to build a neural network to reduce your, you don't even need to, going forward, you won't even need to really do testing because all this data, we can extrapolate from there. We can build a neural network, and from there, you can actually tell what is going to happen without even running a simulation, without even doing a test. So building this neural network will obviously save a lot of time, but again, you need to have the right kind of data with you, which again, we will need to take a deep look into what exactly you'll have and how it can be used to build the neural network. So again, if you do have that kind of data, please reach out to us and we will see how we can work with you to use it to enhance your processes.
Perfect. Another question that we have is, what are the licensing options for Simcenter?
So here we are flexible. It could be, so if it's like a defense organization, typically they tend to look at something more perpetual, like a permanent license. We also have subscription licenses. We have hybrid SaaS, and Siemens as an organization is completely moving towards getting all these solutions that I spoke to you about, moving everything onto the cloud. So already StarCCM is available on the cloud, but other things will slowly, one by one, they'll be brought onto the cloud. So we are very, very flexible and open with how we do the licensing. Now, we also do offer, like in Simcenter 3D, we do have tokens available. So let's say today you're doing only structures and durability, but in the future, so at some point, you realize, okay, I want to do acoustics also. Now, I don't want to you don't want to have to buy a completely new module then. You just need these tokens. So I can do structural, I can do, with these tokens, I can do structural, I can do acoustics, I can do NVH, I can do durability, I can do all these different aspects that are there in Simcenter. Everything is acceptable to me. Everything is accessible to me as long as I have enough tokens. So now each different physics will pull a different set of tokens depending on your applications. So again, if you want to use this thing, and we can tell you for your particular applications what the token counts you will require are, and then you can just buy those amount of tokens and you have access to all the different kind of physics, even if you're not using a particular kind of physics at the moment. Now, if you want to run concurrently, you may need more tokens, but if you're using them individually, everything will be accessible within a very small token count.
Perfect. All right. Lovely. So we'll take one more last question before we call it a day, before we close, since we have already exceeded time limits. So I think I'll take one more last question for you. The question is that how does Simcenter 3D handle all the multi-physics with a single model?
So so this is something that I mentioned earlier during. Basically, you have one model so Simcenter 3D is basically has the entire CAD capabilities of NXCAD. So normally preprocessors tend to have very, very basic geometry editing features like there's an industry benchmark tool for meshing, which is it kind of uses if you want to create a surface, let's just say a square, first you have to create 4 different nodes, then connect those nodes with lines, then connect those lines to create a surface, then you can mesh that surface. In Simcenter 3D, it's as simple as start point and end point, and your surface is created. So you have the full capabilities of a CAD package within this Simcenter environment. Now, with this model, you just need to mesh it once, and then you specify your boundary conditions for your, let's say, it could be the durability analysis. Now, later, if you want to use that same model to do a acoustic analysis, you can use the same model. You don't need to remesh or anything like that. You just there'll be slightly different boundary conditions. You just need to specify those boundary conditions, and the same model will run in the same environment. So basically, all these different use cases are created as different cases within Simcenter, and each of them addresses a different kind of physics. Now, if I want to do multiple physics also, like let's say thermomechanical or vibroacoustics, something like that, everything is available within this same environment. So you can do coupled analysis of different solvers within this single environment. So the limit is only as much as your imagination. You can do practically anything in this environment. I'm sure that you saw in one of those videos, there was a simulation of a person breathing and if their throat constricts, how it's going to restrict the oxygen in the body. So, the sky is the limit as far as simulation is concerned. If you can think about it, you can do it.
Very rightly said, sky is the limit. So that's excellently put. So yes, so those were our questions, Mr. Sushil, from our audience. Ladies and gentlemen, if you have any more questions for Mr. Sushil, please send them to us, and we'll be happy to take them offline and get them answered for you. So now we will be closing this excellent webinar that we were a part of today, and I would like to thank our wonderful audience for being a part of it. I would also like to thank Siemens Digital Industries Software India and our speaker today, Mr. Sushil Samuel, for collaborating with us on this webinar. So thank you all very much, and we'll see you next time. Thank you.
Thank you, everyone. Thank you, Julie. Stay safe.
Stay safe. Bye-bye.